All right, we're going to look at some review questions for our quiz. My first one is, what is the range? So to find the range, the first thing we need to do is get the vertex of whatever we're working on, because the vertex is going to represent either the highest or the lowest spot on the function, and the range is just it's the list of all the y values that the function takes on. It's how far low and high it goes. So for this first one, it is in vertex form. So my vertex is just going to be the opposite of this number and then the regular of that number. All right, my vertex is going to be +9, -4. Nice. And then this 3 right here, this tells me that it's opening up. All right, so I could draw a quick graph of this thing to kind of get an idea for what my range is going to be. 9, -4 is going to be over here somewhere. And then I know it's opening up. Okay, so the range of this function is how low and high it goes. The range is going to be from -4 to infinity. All right, -4 is the lowest. It's the y value of my function. It's the lowest that it gets to, and then it goes upwards from there. All right, another way to describe the y values would be y is greater than or equal to -4. All right, you got your algebraic notation, and then this one over here, this is your interval notation. You could see it either way or both ways. All right. The next one, we're going to find the range of this function. We need to do the vertex again in order to find the range, but this one's in standard form, so it's going to be a bit of a process. In order to find the x part of the vertex, we're going to do -b over 2a. All right, and that's going to give us -8 over 2 times -4. All right, my b was 8, and my a was -4. If you simplify this, you're going to get -8 over -8, which is equal to 1. All right, that's the x part. And then to find the y value, you're going to take that 1 and substitute it in for these x's right here. Okay, so it's going to be -4, 1 squared, plus 8 times 1 minus 2. And if you work all this out, you're going to get +2. Okay. So this is going to be the y value of our vertex. And this one is opening down because my 4 here is negative. So on this one, the range is going to be -infinity, because it's opening downwards, up to 2. 2 is going to represent my maximum on this one. Or if you wanted to write it in that other notation, it would be y is less than or equal to 2. So I know whenever it's in standard form like this, finding your vertex is kind of a pain. So if you want to, you can just graph it in your calculator. -4x squared, and I need to change this. This is supposed to be a positive plus 8x. Again, to get here, you just go to the y equals menu at the top left, type in your function, and then hit graph. All right, and this is how you could figure out what your graph looks like. Press trace, and you could just kind of arrow over to the vertex. If you type in 1, you see that the vertex is 1, 6. Did I do this right? Because I thought I got 1, 2. Oh, it's a -2. Okay, plus 8x. And it's supposed to be a -2 there. I had both my signs wrong. Trace 1 for x. There we go. So the y value is 2. 1, 2 is my vertex. Okay. This next one, what is the domain? So the domain, it is the set of x values that the function takes on, or it's all the numbers that you are allowed to plug in for x, right? And for all quadratics, there's actually no restrictions on the numbers that you can plug in for x. You could let x equal any number you wanted to, all right? And it will come out to a reasonable answer. It'll just come out to a number, whether it's big or small, right? Or graphically, if you wanted to graph this thing, it's going to cross at -4, it's going to cross at 8, and it's opening down. So I know it's going to look something like this when we go to graph it. And for the domain, it's how far left and right it goes. Okay, so the domain of this function is all real numbers, or you could say it's -infinity to +infinity. Okay. All right, the y-intercepts, these are super easy. Okay, you're just going to plug in 0 for x, and that's how you find your y-intercept. All right, again, if you want to, you could graph the function and then kind of eyeball what the y-intercept is, or press trace and then 0 for x. All right, that could be how you find the y-intercept, but it's really easy to do it by hand. All right, if you plug in 0 for these x's, you're going to get 3 left over and -4 left over. All right, and we're multiplying those. So my y-intercept is -12. All right, this one's in standard form. Again, if you plug in 0 for the x's, these two terms are just going to cancel out, disintegrate. And so you're going to be left with +8. That's your y-intercept. All right, for this one, we'll plug in 0 for x. We're going to have 0 plus 4, which is 4. And then 4 squared is 16. And then we do 2 times 16 is 32 minus 20. And we get +12. That's our y-intercept for that one. Okay. The x-intercepts. So to find the x-intercept, you plug in 0 for y. There we go. And then to solve this one, because it's in factored form, it's super easy. You would take each of these factors and set them equal to 0 and then solve. So we're going to get x equals 1 for this factor. And then for this one, you take 3x plus 4, set that equal to 0. And when you solve this, you're going to get x equals -4 divided by 3. Okay. For this one's in standard form. So you could use the quadratic formula in order to solve this. You would just use a 0 for c. This one we could solve by factoring because they both have an x in common. Actually, they got a 4. Yeah. I'm going to factor out a 4x from both of these. That's going to leave me with an x minus 3. Yeah, 4x times 3 gives me 12x. Okay. This one right here, if I set that equal to 0, x equals 0 is going to be my answer. And then for this one, x equals 3 is going to be my answer. Okay. And again, if you want to, all right, 4x squared minus 12x, we could just graph this thing and look for those x-intercepts, physically. Zoom standard. All right, we could just eyeball what those x-intercepts are. Trace, you see one of them right here is at 0. The other one is right here, and it's at 2.97. But if I punch in 3, there you go. There's our x-intercept. So the x-intercepts are just the numbers that you have to plug in order to get 0. Okay, for this one, we got vertex form. -60. To solve this one, I'm just going to do inverse operations. So I'm going to plus 60 on both sides. X plus 2 squared. All right, now I'm going to take the square root of both sides. So I get plus or minus root 60 equals x plus 2, and then subtract 2 from both sides. So negative 2 plus or minus root 60 is equal to x. Whatever these two answers come out to are going to be my x-intercepts. Negative 2 plus root 60. There we go. Negative 2 minus root 60. There we go. 5.74 and negative 9.74. I guess those are actually 5s, aren't they? 5.75 and negative 9.75. Okay. And so if you plug those numbers in for x here, it should drive that function down to 0, or at least something very, very close to 0.